Hello, everybody. Welcome back, people who were here last week and people who are just joining us. This is the second episode of Coding with Some Guy. Last week we had a lot of fun. We took word clouds. We took a lot of words from public companies, and we put them together in the shape of the company's logo, and that came out pretty. That had some very pretty results, and it was really nice because I forgot to hit the record button. So for the 10 or so people that saw it, thanks for watching. You are the only ones. There is. Sorry you missed it, people who are just joining. Um, that's I'll probably get back to that in a few weeks if there's some popular demand. But let's talk about today. Today I'm gonna be. I was a little surprised when I saw how much a Stream Deck cost, and I thought, well, now come on. I mean, custom buttons. I've got this fantastic custom button device that's already been debounced. It has USB capabilities, and it's plugged straight in to my machine without a lot of interface problems, no custom software, and it is called a keyboard. This is new technology, but we're going to repurpose it. We're going to do something very cool with it. We are going to take this magical key input device, and we're going to make it do whatever custom things that you determine. So later on in the show, we're going to set up some bindings and get this to do some pretty cool stuff. So one caveat, this is going to be covering the Linux input API, so that's not really a problem with this stream because you're all using Linux, of course, and that's a good thing. So without further ado, let's get going.
I watched Guy live code a beer delivery system on a 52-inch plasma screen from a beanbag.
Thank you, Patrick. I appreciate you telling everybody about that. So let's get suited up here for the drawing. I want to cover a few things that we are going to be talking about this time. And my paint is our friend, and it's going to do some magic drawing for us. So it's very nice to have magic drawing. This is, so we are in E2 here, and we're doing key magic. So what the way we're going to run this is we've got basically three parts to getting this to work. The first is we're going to have to take that magical key input device, and we're going to have to find it. It's going to show up very differently depending on the type of keyboard you have, but they're all basically going to say wired key input device, wireless, whatever. So we're going to need to find it in the device list, and we're going to have to get that kind of working for us, and we're going to have to shut off the keyboard part of it to get our magic working. And then after we find it, we're going to learn how to take input codes from that, and we're going to be using the UAPI, which is a convenient tool. And oh, hey, what's up, F2O? Nightshade, good to see you guys. So we're going to take that user API, and we're going to decode those events and get them rolling. So then as soon as we've got that all set up, then we're actually going to get to the fun part, and we're going to do some magical bindings. So with that part, it's we're going to be writing in Python today, so that part I'll sort of leave that up to you. I'll get a few samples to get that started, and that's basically it. So, uh, drawing stuff aside, let's get to the action. All right, I'm gonna just because you're all great people, I'm gonna top up the mana here. I can only program as long as I've got mana, so we're gonna keep that going. And the target here is going to be about a little less than an hour. So we've got our fresh new directory, and we're ready to go. So um, I've got yes, the time lapse, by the way, in the beginning is me making the mana bar. So that's I figured you got to top up the mana to do some programming. All right, so we're going to and nice for those of you who know about the other things. Okay, so we've got nothing in here, and we're going to get started with our Python 3 app, which we're going to call I don't know, what should we call it? Key handler. And this just takes some of the dirty work out of having to do all that nonsense. And once again, I'm going to be using screen and some other magic that mostly Vim. So sorry for you people that aren't Vim people, but hopefully this text is going to be fairly readable on your screen. I know the stream likes to kind of crush it a bit. So we've got in here our little start. We got basically nothing. So we like getting going with our main. And before we do that, I've taken the liberty of taking this key input device and connecting it already. So it's going to show up on my USB. Now, the user API has a nice feature that it puts the input devices here. Now, I've got a bunch of input devices on this system, including the camera and the headphones and all that other fun stuff. So which of these 30 now keyboards show up as event interfaces. They create key events. The mice, they're all unified in that mice file over there, and that we have a lot of events here. I mean, this is like, I mean, there's 30 of these, so I don't really want to go digging around to find that. But Linux in its infinite wisdom gives us this nice little by ID. So, and if we look in here, we can see this happens to be a Dell keyboard I just picked up. I was using a Amazon Basics keyboard the other day, which I was able to get for $10. So this is very expensive hack, but I'm putting that out there for all of you. So this there's a few interfaces that show up. We're interested in this guy over here. So this is the actual keyboard interface, and that links itself nicely. Well, sorry about all that. That links itself nicely to event 15 and event 16. So that's actually where our keyboard is connected. Now, to fully finish this, you're going to have to do some UDEV magic. And the one thing that I want you to be careful of if you try this at home, and you should try this at home, is, oh, I don't want to CD into it. I want to show it to you. You need to make sure that you are in the right group. So by default, you're probably not going to be in the input group, which sort of makes sense because X is normally the one that's going to be handling all that. So for today, to keep things simple, I'm keeping the UDEV out of it. So we're just going to go, and I've put myself in this group. So I should be able to cat this thing and actually read the interface. Now, it's not doing anything at the moment, and that's fine. So there's another little bit of magic we need to do there as well, because keyboards normally, if you type on them, like I'm going to type on this guy, then it just sends keys and decodes them and does all the things that it's supposed to do with a keyboard. So we don't want it to act as a normal input, as a normal keyboard. So in order to get around that, we're going to need to find it in this list, which has slightly different names, although it does tie to the same IDs in the event system. So we're just gonna look at that for the wired keyboards, and now we see that we've actually gotten 3 because X has done a little bit of magic and slaved it, and so now we actually have 3 keyboards here. We're going to disable all of them because we don't actually want them to be in use by the system. So that's this is how we're going to find the device, and then we're going to actually go and disable it a little bit later. So what we're working with here is a bunch of files, which is really nice. And for those of you who used other versions of Unix, a little bit older, there's not much in dev other than just raw devices. And in dev and proc and sys and Linux, you actually have a whole wealth of information about your system. So it's nice that the interface is so simple to work with. So I'm just going to shorten this today. I don't have any other Dell keyboards, but they all seem to have this this string. So we're gonna take that as the X input keyboard string. And we're also going to need the device, the actual device name that this thing is called in the by-id folder. And that is, I'm going to get a full path here because that's what I want. What was this thing? It was, okay, so I'm going to take this one. And this is what we're going to use for our actual input events. So you can actually get from one to the other. It involves looking in the X input protocol, and it's kind of a mess. So we're just going to use X input, let it deal with the X isms for us today. So this is the, well, let's call this the input. I should really make these constants. I'm not being very Pythonic. So there's our keyboard. I'm just going over the line limit. And so this is keyboard name. So this is this. All right, so we're set up. We know which devices we're talking to. Getting from this to that is just a bit of a mess. X renames a bunch of the inputs, so we're just going to use the X input list if you forget on your own. All right, so what do we want to do? What kind of format does this keyboard generate? This is just basically a normal device input file. So there's not. It does have a few special properties, which we're going to get from the Linux kernel, which tells us everything in its documentation directory. So where do it's just handy that I happen to have this downloaded and uncompressed for you. So this is a recent Linux kernel, and in here there's just a wealth of stuff, and there's all kinds of information on the input. So input happens to be here, but I'm going to show it to you in the browser because it's nice to have a few things open. All right, so if you open up this file, this input.rst, then you end up with this down here at the bottom. You get this event interface, which is actually going to be, this is what we're interested in. So keys, it's telling us that we're going to be able to find these things in dev input event, like I just showed you. It's a little tricky to figure out which keyboard's which, but we're going to use the by ID convenience directory to do that. You can also do it by USB device ID. It's really up to you. That's probably more important if you're doing the UDEV version of it. So we'll leave that alone for now. Now, when we open this file, it's basically going to show up as a binary file, and every time I press a key, an event like this in this structure is going to show up. Now, this is for those of you not used to reading C structures. This is basically this is a embedded structure. We have this input event structure contains a time. That's when the key was pressed. I think it's a relative offset from the last one. And it's going to be called time. So then this time value is a little messy to decode. Then we're going to have a type, which is telling us what sort of event happened. In the case of a keyboard, we're going to be looking for a key press, which they tell us down here is going to be EV key. And it's also going to give us a code. Now that's the scan code on the keyboard. So we're going to use that to figure out which key was pressed. And we have a value, which changes depending on what type we have. And it's telling us down here that the value is now we're going to be dealing with EV keys. We're not dealing with joysticks and all the other fun stuff we can input here. But by the way, if you hook a joystick up, it shows up in this same interface if it has a proper kernel driver. And the so EV key is going to give us this value here of 1 for a key press and 2 for an auto repeat and 0, which is for a release. So key down, it's going to be 1. Key up, it's going to be 0. And if I hold it down, it's going to be a 2. So we're just going to be working with key downs, but we'll get to that a little later. Now, because nothing in life is simple, this time val is defined very in a very complicated fashion, and that's really due to compiler stuff around if your machine is 32-bit or 64-bit and what sort of time units you're using. I'm going to kind of skip over that. The it's just a normal time value, which you can see in your man pages here. So it's one of these, which looks nice and simple, except that this type basically ends up on x86-64. This is a 64-bit signed number. I don't know why it needs to be signed, but it's what you'll find if you go dig around. And this ends up being a signed integer, except that because that would be 4 bytes. Well, yeah, you have a long here basically, and 8 bytes on a 64-bit, and this would be 4 bytes, then it pads it out to add an invisible parameter that is not being shown here, which is going to be another 4 bytes. So enough talking about it. Let's actually go see it. All right, so we're going to try to open this guy up. So we're going to open I'm going to make a note here to remember that we're going to disable X input, and we'll get to that a little later. But for now, we're just going to open up this input device, and it is coming across in a structure that's binary, so make sure that you have that B, because otherwise you're going to be in a world of pain. I'll see you later, Nightshade dude. Thanks for dropping by. All right, so I'm going to open that up as a normal file, and I need to know how much I'm going to read from it. Now, to calculate that, we're going to use a little convenience routine in Python to deal with C structures. You could use the Python stuff. I want to try to keep this simple. So this structure, we're going to need to know how big this event over here is. So we're gonna calculate it right now by first specifying the format, and I just want to make sure I don't show you the wrong thing. And yes, okay, so this is going to be in local notation. We want to make sure that this is applicable to this system. Now, we know that the first part of the time is a long. We know that that's the seconds. The second part, the microseconds, is an integer, and then we have some padding. So that's going to get us through this part. So then we have the type. We have 2 shorts here that are both unsigned, followed by a value. So to get that, we're going to take our 2 shorts, and then we're going to just take our normal int, except it's unsigned over here. Now, in case we forget, and trust me, I forget this all the time, what these things are, Python is handy, so we can just go and look at what all these things mean. Now, in here we see that this is our unsigned short, and this is our unsigned integer, and our long, which is signed, is going to be a lowercase l, and our unsigned, well, we're not using an unsigned long. So if I just split this for everybody, then we can look at this and check that we got this right. So here we have the long. All right, so this is our long, and then we have the integer, and we have another integer for padding, and then we have our our unsigned short, which matches up what we're seeing over here. And we got two of them. And then we've got our regular integer. Okay, so that should be the description of the event. So using that, we are going to calculate how big it is, because we need to know how many bytes to read. All right, so we're going to take that size, and we're going to call this the input event size. All right, so our constants are out of the way. We're ready to get reading. So here I'm going to take, this is very complicated Python code. I'm going to just read the size of the structure. That is my raw event. So that's not really a, this is basically going to read however many bytes corresponds to that that structure that I just spelled out. And if I got it right, then they should match. This event interface tells us that you can either block or not, and you'll always get a whole number of events on read. So I don't have to worry about like getting part of a structure and waiting for it. The kernel is going to guarantee that I get the whole thing, which is handy. So I'm going to get this raw event, and then I'm going to print it out, because why not? Right, so I can just, I activated this. I can just run my key handler. I can press a key, and I get the binary structure. Now, we don't really want the binary structure. we actually want to take that apart. We want to pull out the fields that are specified. So because I don't want to do too much inside this routine, I'm going to decode the event, and I'm going to pass it up here, and I'm going to make a routine which takes this raw event and actually makes some sense of it. We're going to use struct unpack to read all of those bytes that are in that structure and put them into Python, a Python tuple. So let's unpack this using the input event format, and we are going to end up with a Python kind of event. So you know, really the hardest part of all this is going to be naming things. So I'm just going to call this an event tuple. It's very original, some guy coding. So I'm going to take this thing and I'm going to print it out. Now, thanks to the magic of Python, I press a key on that. Oh, I forgot to actually pass the event. Let's pass the thing we wanted to code. And we're going to hit J, and there we go. The J key shows up, and now we have this decoded. So here is our number of seconds. This is our number of microseconds. This is the padding, so this will always be 0. And here's the actual fields that we care about. This is the type, the code, and the value. So let's be good people, and let's pull this apart. Now, we don't really want to read just one, but before we get to the actual decoder, we do want to make sure that we're going to end up disabling this thing. So the inputs that I'm going to need to disable all look like this. I think it's probably better if we just do them by hand. We can actually parse this, because what we can do is we can look at our X input list, and we can look for all of the lines that have the keyboard that we want to find in it. And the handy thing about this thing is we have this nice delimiter, which is going to, this down arrow Unicode is going to tell us exactly where to start. And then there's a few tabs, and then we're going to go to the end. Now, don't you worry, I'm gonna do it without a regular expression, but maybe we'll use a regular expression. Don't tell me. All right, so let's actually disable this. So to do this, we're going to use, we're just going to read that file that I just told you about, and I'm not going to use subcommand because I don't care about the command arguments for now. We basically want to see the results of input list, and well, let's just read all of it. this, we're going to end up with a bunch of lines, and we're going to search for that particular piece of Unicode is be more Pythonic. This is the Unicode for that. So you can also, if you are wondering where that comes from, you can just do it the really complicated way, or you can, and you're going to discover that this is really at the Wikipedia. And if I search for it, I will not find my event type. Yeah, it's this downwards arrow with tip right words. It's this guy. Oh, hey, what's up, Katie? Cody. Sorry, my bad, dude. Wasn't looking here. Yeah, let's run a regex and a tight loop. You really came at the most inopportune moment, but I have beef with regular expressions, as some of you may know. So, but just because Cody's here, I'm not even going to bother to parse this. I'm going to do this for him. So let's get that tight loop that he's talking about. Let's. Thanks, dude. We're gonna go and we're gonna split this line up. Now we need to give it a pattern. We're gonna be cool and use a regular expression on the line. And let's say that we have a whole bunch of stuff, which is, I don't really need a regular expression. Let's just be good people. Let's make sure that we have the actual. We're only interested in the Dell keyboard, so let's look at that. We don't want in. We just want to see that it contains, which no, you don't get contains. What do I want? I want the starting off. Should we just say if it's in there? Yeah, we could just find it. Yeah, and then if we give it something it doesn't know, yeah, we'll just use a find. Okay, so this is find this thing is not equal to -1, then we know that it's in the line, and we can just make sure that we're hitting the right line. So let's go and do that. Yep, we're cool. Okay, so there's our 3 keyboards, and we need to just pull out after the Unicode thing, and this will be, here's my great naming now. Okay, so we just want to get that and everything up to the, excuse me, everything up to the, I'm going to write a very Perl-like line. So we're going to take, that's going to match, I mean, I guess I could check if it matches, but it's going to match everything up to the tab. So let's take this and split it again and do everything up to the tab, and we end up with the right thing. Okay, but we want to drop that first character because we don't really want that, so we're going to slice it one on, and that would be not the right thing to do. Okay, so, because I returned an array, so first I need, there's some Perl. You like that? Okay, so there's my keyboard, except I've got this annoying little space here. So we're just going to get rid of that space. I know, it's fragile, but hey, I didn't use a regular expression, so sorry, Cody. I'll save it for next time. All right, so Spirit Researcher suck. Oh no. was trying to put SSL on my website, but Nginx up the code. I need to start the web server anymore. I have autism. Can help me. Yeah, that's not really on topic. So sorry right now. I can tell you that setting up SSL and Nginx is not the most fun you're ever going to have, but there's some great guides for it on the internet. Okay, so this is going to be, okay, so now we have the right names. And once we have those names, all we have to do is, it's really X input keyboard names. Actually, I only get one at a time. And because I don't want to do another tight loop, I'm just going to build a magic command that I'm going to system, which is going to be X input disable the thing that I've got here. All right, and we're going to twist in the keyboard name. So that should look right. Yeah, it does. Cool. All right, well, do it. All right, there's a million safer ways to do that, but now when I type on this keyboard, I get the key input event, but no keys are coming through, so it's no longer bound into X. Um, yes, Cody, I completely agree, and no worries, Spirit. I just we'll get to Nginx in a future stream, I'm sure, but for now, it's really it's a lot of fun. um, okay, so and thanks for dropping that link, Cody. Much appreciated. So now I've got the keyboards disabled, and I'm ready to go do that. So we don't really need to see these commands anymore, so I'm just going to comment them out. All right, cool. Um, now, now that I've got the actual event, I need to, well, let's do this forever, because we're just going to run this sort of in the background. So I go and I get keys, and there's a whole lot. Now you might notice that for one key event, I'm just going to press an H here. I'm getting a lot of stuff, okay, and that's I'm not really interested in these times, but and this padding is always 0. But what I'm going to end up getting here is this is the type, and this happens to be a mistype. We'll get to that in a sec. This is going to be some. I don't want to look at that line. I really want these lines with a 1 because those correspond to EV key presses. So this isn't an actual key press. And this is telling us that it was a key press and not a key release. This is telling us this is the end of that packet. Sorry, the actual key release is over here, which is basically the same scan code, that 35, which corresponds to the H, except now I'm releasing it. So this last field sort of changes depending on what the record is. So we don't really want these, so we're just going to filter them out and do it without using an observable. Sorry, I couldn't resist. So this particular input, let's unpack it. So the actual event, the parsed event that's coming in is really going to be made up of, this is the tuple. We have the event, this is the TV sec field, the first part of get time of day, which of course I closed. Yeah, so this is the TV sec field, and that's our seconds, and then we're going to have the TV usec field. Try to stay consistent naming. And then we're going to have the TV pad, which we're not very interested in. We could really just drop it on the floor, Python style. And then we've got the 3 that we're really interested in. So this is our type, our code, and our value. So this is our ET type, our, well, I'm going to refer to these by event because that's what it's called over here. So this is our EV. This is our EV type, our EV code, and our EV value. All right, so we're going to unpack all of those from there. And the ones that we're really most interested in are the type, the code, and the value. Okay, so now I press a key and I get a lot less fields. All right, now I only want these ones where the event type is 1. Now to actually know that, I'd have to go, it does mention down here that you can see input codes, and if you dig all that up, you'll find this file, which is also included in your kernel source, which is available, or you could even look at it on GitHub like I am right now. Oh, sorry, this is GitHub. This is the actual kernel we're looking at. Now, if we go over to GitHub, we'll find, oh, look at that. Event types are just sitting right there waiting for us. So this is all of the types that we need to deal with. We're now just, this is really an enum, but, kernelisms, we're going to do this as defines. So these are all the types that could show up. The one that we're interested in is right here. This corresponds to this one. So this is EV key. We're doing keyboard events. We had better not see joystick inputs coming in from the keyboard, at least not this keyboard. So because we're good people, we're going to use a constant, and then we're going to, we can extract that constant later, and we can say if the EV type is the EV key, then I know that I'm getting a key event, then we're going to print it out. So we do that, and we're only seeing key presses corresponding to, oh, and see, kind of multiplex things there if I press 2 at a time. So here we're just going to get the key events, and we're going to get either it was a key down or a key up, and this is the actual scan code. And if I hold it down, I'll get a 2 and a release. So this is the actual, this is a repeat. So this is generated. I'm not actually pressing it. I'm only going to be interested in these ones here. So now they don't actually refer to what this value is called. So we're going to have to make up something. But we're okay with naming some things. So we really want, let's do just, sorry, looking at C code. So we really want just the case where the value is 1. So that corresponds to a key value. Let's just call it key press. All right, so yeah, that's going to be a 1. So if the value is a key press, then I guess we should be more specific. This is a key down. Then I want to print the thing out. So looking at this, yeah, now I'm only getting key down, so I don't have to worry about it. If I hold a key, nothing happens. All right, so now we've kind of tamed that particular input. So going back to here, this is we've found the device. It was hidden in the dev system, and we then figured out how to actually parse the input, and that's the UAPI that I was talking about. And now we get to the fun part. So I'm going to give you a little moment for participation if you're interested. And I know Cody is going to make me write a regular expression, but that's just going to happen. I'm not going to do that. There are limits. So go ahead and what do we want to get one of these keys to do? Well, actually, I mean, it's a little tricky to know which key is which was also defined in this file because there they are. Now, this is based on the USB scan codes, but this actually tells us how we're going to process this code field. So that corresponds to all of these keys. So key whatever. Now, because I don't want to read this file and parse it and do all sorts of other nasty things, just because I love all of you, I have gone ahead and not see. There's the episode 1 you missed, and we're going to see from right in here that as a great friendly dev, I took this file and pulled out all these values. Now, some of them are actually computations. So if you look like a little bit further down, you'll see some stuff in here. Oh, these are buttons. Sorry. I remember the one that was Hangul with both spellings. So this could actually be, you could see that this is like scan code 122 is this key. And here it is again, but now with the U and the E changed. So that's a lot of fun. But I love that there exists this key. By the way, I don't know why my keyboard doesn't have it, but there is actually a coffee key, and I just in honor of you, coffee key. Such a good key. I need that key. I don't want this key at all, and that's kind of scares me. But there's all sorts of fun keys in here. Like I need to get this to do something interesting, but we'll worry about that a little bit later. We are going to cycle Windows plenty of times. So instead of processing all that, I'm going to just take this, except I've got the reverse problem. I get a scan code and I want to get the key out of it. So save a little time. I went and I reversed that list for you. Of course, now they're quoted because it's a dictionary, and JSON wonders. But if I look down here, I've got my, oh, did I pull the coffee key out? Oh no. All right, well, there's some parsing fun going on in here. But oh yeah, it would have been 152. That's a bummer. Also has screen lock. Oh, I overwrote it. All right, so it's not a perfect file, but basically this will get us for a given scan code, this will give us a one-to-one mapping to which particular button it is. I'm just curious. Okay, yeah, so it was when I dumped the thing out. I've actually got the coffee key in there, but in the other direction, we've only got one position for a 152. I don't want to make this a complicated data structure. You can do that on a whiteboard interview if you want in Silicon Valley. Just go ahead. That is absolutely where we're going, F12. That's what we're doing. We are making that thing. I'm not gonna say what it is, but we can actually do anything we want with it. So I shouldn't say that. We can do anything we want for key input, magic key stuff. So how do we actually decode this thing? Well, let's read that file. So that file we have over here, this thing, so it's that and scan codes. We want the reverse mapping. So I'm going to take that as scan codes. I really want to mention that it's a file. Okay, everything. Yes, Whiteland. So we're going to read that thing in, and we're going to decode it. So it's not too much trouble because I already packed it up in JSON, and we already have JSON here. So we're going to do a little JSON load of a file, which is called the scan code file. Now this is regular ASCII, so I don't have to worry about it. And I'm going to end up with my scan codes. Scan code decoder. It's my secret decoder ring. So let's just make sure we got that file in there, right? And there it is. Okay, so now the only catch we have to watch out for is these are strings, they're not numbers. So we have to remember that, and trust me, I will forget it. But you're all gonna tell me when I forget it. You're gonna go, guy, it's a string. So let's go and let's decode something. So we have the EV value that we don't care about we have the EV code, which we do care about. This is the scan code. So we're going to use the EV code, except just before I forget, I'm going to just turn it into a string because I know I'm going to forget. And I'm going to look just to make sure it's in my dictionary. Actually, let's just call this the EV code string. I just don't want to forget, and I know I'm going to forget. So let's just make sure that that's in there. We'll be actually, if we type a key that doesn't show up on, all right, we'll be safe. All right, if EV code string in the scan code decoder, then we're going to print that thing out. Well, we'll just leave this printing out normal. But for debugging, but we're going to look, because printf debugging, and we're going to just see what this corresponds to by taking the decoder and looking for this thing. And we don't want to see every single key anymore. Bad guy. Hey, that's a J, that's a K, that's an L, that's an N. And when you're off by one, these things end up being kind of crazy. So we can also check our little magic keys. We've got all sorts of fun stuff here, but we don't have a coffee key. You'll notice that the key codes are different on the keypad. So keypad 1 is different from regular 1. You all know that. But we get our F keys as long as they're not bound to anything. But I don't have to worry because this is not going through X input. So whatever I type on this keyboard, it's not going to end up messing me up. So some of these keys, they're acting a little funny. I'm not really sure what happened on this particular keyboard, but we are getting all of the normal keys. So now that we have key names, we can actually go and do something kind of fun with them. So let's process key. All right, F2O, you're the one who figured it out. So what do you want the first action to be for our processed key? Key name. Okay, I'll be Pythonic. F2O. Just going to make sure I sent the right thing up here. Yeah, I did. All right, cool. You obviously need a key to add some mana. Okay, that's actually a web thing, so that would be like a whole other, because then you have to build like a web socket and but ordering coffee. All right. Well, yeah. Well, we could. I don't want to pick something that's already open, but let's try ordering coffee. Ordering coffee sounds good. What do you think? C is a good. Yes, I'm positive we're gonna have a coffee shop REST API. That's. I like where you guys are going. Okay, so let's let's do it. Let's turn that into a URL. So we'll do a giant if block. Actually, let's just make a command dictionary. So we're gonna say if we get a key C sound good? Yeah. Then we're going to open up a browser. So let's pop open Chrome and do I want Chrome? No, I don't want Chrome. I want Chromium. All right. So let's pop open Chromium and make sure we're in incognito mode. And let's go to DuckDuckGo. And I think you just need a query on them for a coffee API. Gonna manually escape it for now. All right, so and just for error checking, let's make a query to see. I do nothing fun. All right, so if key name is in our commands, then we can take a look at what we're going to get if we do this. Okay, K is not there, but Q is there. Okay, and of course we've got our coffee key. All right, neat. So let's do it. Nothing could go wrong with this sort of code. Haha. Okay. Um, so let's. Well, it actually told us I do nothing fun. Oh man, there you go. Bob's your uncle. So there is actually a coffee API. I didn't know. I don't know what's going to happen. Oh! You know what? This is going to lead to something very good because I think we're going to have to cover that in another stream. But this is the most insane protocol on the internet that I love. This is an RFC for the HTCP CP, and if you're not down with the HTCP CP, you're just not ready for life. I mean, it's just... Now, the one problem we got here is, of course, I forgot to put this in the background. So we're going to just fix that real quick. And we like quoting things, because even though we're doing it... All right, so we're just going to make these commands go in the background. All right, great. Now, let's get down with the HTCP CP. The Hypertext Coffee Pot Control Protocol. That's right, RFC 2324. We are ready to make this thing brew coffee. So I'm going to go get a coffee machine. Okay, no, we're gonna do the coffee machine next time. But no, not next time. There's actually a schedule, but I'll put that on the list if you're all interested in it. So the the Hypertext Coffee Pot Control Protocol happens to have something that some of you may have run into on the web, which is about the 418 error message. This is actually what it comes from, for those of you who don't know. But sometimes you might get these are HTTP CP return codes. They're modeled on HTTP. There is the not acceptable, but more fun is the 418 I am a teapot. You can't send HTTP CP commands to a teapot. That's just not covered. That's a completely different thing. So Cody, we're gonna build it. We're not gonna sit around waiting for a coffee pot. I don't even know if there is a coffee pot that CP compatible coffee pot question mark. I no, it's not. Is it K-cup compatible? I don't care. Is it? No, see, I don't know where I buy this thing. I don't. Where's the shopping? I mean, can Google do better? I mean, HTCP. Oh, they are just updating their terms of service all the time. Is that just a permanent part? All right, I don't want to get into that. Compatible coffee. No, devices. Nice. Someone must have built it, but clearly no one's selling it. So we're gonna make one of these. Not now. So getting away from the coffee pot control protocol, this is actually that's it. You got that's your Stream Deck. I can hook this up to an event interface. I can hook it up to OBS. And get it to change scenes, and that's what I'm going to be doing. Believe you me. But we might just have to go get a coffee pot for where we're going next. Now, this this actually works with just about anything, as you saw. So I can go in here and add whatever. I mean, let's add XIs, for example, which unfortunately will not stream for me. So we're gonna close this guy, and we're gonna go look for our XIs. Now, XIs popped up here, but you're not, unfortunately, you're not able to see it. So I'm gonna throw it over here on the whiteboard for you. And there it is. There's our eyes. I can I can go ahead and add more. Now, what's cool about this, it doesn't matter what application is active because this is not participating in the X input system. So whenever I hit a key like that X key I just added, I can I can go as crazy as I want here. Oh, whoa, that's some serious eyes. Now we are not good. We're going to want to get rid of all those eyes. Yeah, that's a. Let's. Can I just? Yeah, you guys got to go. I'm sorry. It's a rough death, but anyway, that very cool that it works pretty much anywhere where I am. So I can be scrolling around and wondering what's going on. Oh, what was the coffee pot control like? Oh yeah, there it is. That's where I find that. All right, so I think we've gone ahead and shown you what magical bindings means. Except I can remember that this is a touchpad, and I can just go ahead and draw all over it. So I think we've gotten our share of key magic here. In fact, I'm so happy with it that I'm just going to change colors for all of you. And when I'm done with my terrible artwork, my God. All right, I don't know. That it looks like that, but not really. So when we're done with all that, we're going. We can have some fun. We basically just build a stream deck. This can be done. X input and all of that stuff. There are a bunch of compatibility libraries for Windows. I don't want to get into it though. I mean, someone who's more motivated than me on that can feel free. I'll drop this code off somewhere, but you can get it from the stream. Um, I, yeah, I do think we're going to need to turn a cheap coffee pot into a smart one. One of the things that I've always loved, I did work briefly in consumer electronics, and we had a habit, robotics stuff. This was some my time over in Hong Kong, but we actually we used to joke about smart because usually whenever a product involves, and this is something that Scott actually is huge on. He was over at he's Xflix too, but he when you put smart in front of a device name, that usually means it doesn't work and it's very expensive. So like smart coffee, like nobody wants smart coffee. Like we want coffee and we want it to work. And I mean, smart has that. I mean, but I don't want to call it IoT coffee. I guess that might be a little more modern. Um, oh yeah, thanks F2O. I appreciate it. That's I do practice this. This stuff takes some prep, but trying to be dense and give you everything within an hour. So if if I can stick to that, I think I'm going to be pretty happy with how that's going. So I don't have this is actually that's pretty much where we're going to stop that. So I have a few other. I mean, there's a whole season already laid out. So I yes, that's a great idea, Cody. I have a there's a whole season. There's a lot of stuff. I'm gonna post the schedule. I meant to do it before today. I just didn't finish. There was some issues with that padding that I showed you earlier to get that. Why is that always zero? Yeah, this number's not that big. Yeah. Anyway, that's the part that I don't think is really fun for the stream. But the next week I'm going to be covering. It is going to be another hardware hack. I've got a. We're going to be working with a rotary encoder. So for those of you who don't know, that's kind of like a pot on a. If you're familiar, it's a potentiometer. It's very except it has no limits. So a potentiometer, it's like think like a volume switch, so like classic volume switches, like you turn it all the way to 0 and it's limited, and then you turn it all the way up um, to 11. But this they have limits on that, and that's actually working by resistance. So a rotary encoder basically kind of does the same thing, but it's different physics. It's infinite. So instead, it just encodes whenever the wheel is turning, rather than having limits. So it's better for infinite kinds of devices. For those of you who are going to be around, you're actually going to get a little bit of a surprise. I'm doing Lux Jam. So I told Lana Lux that I would participate in her jam, and I didn't really have any time to work out a programming toolkit, so I'm going in basically blind. This is going to be a live learn session, and it's not part of the normal season, so I'll mark it correctly. But the Lux Jam starts today at 6 p.m. So I'm going to be in some serious hack mode this weekend. So we'll see if we can get, maybe, I don't know, maybe the game will be just hooking up a coffee pot. No promises, but well, I hope you all enjoyed the show. So thank you very much.